Okay. So, hi everyone. Thanks for the introduction and welcome to our talk about programming notations for smart home users. Smart homes intend to make life easier by automating functions like closing the blinds, securing home access, playing your favorite music, or making sure that your coffee is ready when you come out of the bathroom. I'm really grateful for the previous talk to make this point so clearly, that a deep understanding of home technology is unrealistic for the average end users because most of us simply aren't the maker type. But people still want full control over what is going on in their homes. So in order to make smart homes fit for the use by the average consumer, they need an interface that is both easy to configure and it has to offer a wide range of personalized routines. Because the more functions a smart home can offer, the more it lends itself to meaningful use cases. But of course, in turn, this means that the interface is challenged to present increasingly technical procedures, but still in a very intuitive way. When we look at home automation interfaces from both industry and research, we can see that approaches like remote control, static scene setting, or action trigger programming, like if this, then that kind of rules, have emerged. But even though there are a broad set of solutions out there, smart home technology still has the problem that it hasn't really reached mass market. So to kind of tackle that, in an earlier project, we tried to develop a different kind of interface based on process modeling. But the user testing that we did on that interface gave really mixed results. So we decided to take a step back first and try to compare the fundamental characteristics of this process-based modeling with the current, I'd like to say, market leader of trigger action programming to find out what requirements smart home users actually have for configuring their, hopefully soon, smart homes. Up to now, home automation interfaces have mostly been developed kind of on the spot for either for research projects or even for smart home industry solutions. But the effects of the underlying programming notations that are used in these interfaces have not been formally studied, and design guidelines on how to create a home automation interface are very sparse. In our state-of-the-art analysis, we found that rule-based approaches like the trigger action programming seem to be very accessible for quick first results. But when you try to create more complex home automation tasks, they need to be created in the form of very extensive and hard to manage rule systems. And from the background in engineering, rule-based programming often has draws very heavily from actual programming or kind of wiring solutions. So the technical knowledge you need for those interfaces is often much more than is typical for the average user. On the other hand, process-oriented approaches might have a steeper learning curve because they're not as easy as the if this, then that concept. But they could potentially allow users to configure homes leveraging the full potential of the technology by using the hopefully accessible metaphor of a control flow. When we get right down to it, rule-based approaches and process-oriented approaches can be kind of seen as opposing ends of the user interaction spectrum, and solutions that are currently out in the wild are rarely exactly one or the other, but rather a mix in the middle. But to study the effects of the notation characteristics, we decided to distill both approaches down to their core characteristics so we could formally compare them. Rules, in the way that we see them, are essentially if this, then that constructs, where users define what kinds of events, there can be more than one, should trigger what kinds of actions in the home. The use case that you can see modeled here is if the alarm clock is ringing between 6 and 8 a.m. in the morning, make 1 cup of coffee. In the wild, there are several extensions that we kind of saw as more of the control flow paradigm, so we decided to exclude them from the rule definition for our study. Instead, home automation processes can be visualized in the form of a graph, where the nodes stand for devices, where the devices can both have events or actions depending on where they're used in the graph. And the edges denote the control flow of the automation. Additional semantics can be added in the form of logic operators for and or. The use case here is the same one as before, simply used with the process elements. So you have the alarm clock that is ringing, the clock that has the state between 6 and 8 a.m., and then the coffee maker with the action, make 1 cup of coffee. For our study, we chose a contextual inquiry design, and we let participants work with the notation for 1 week and in their own homes to leverage the benefits of familiarity with the devices and use cases on the one hand, and the kind of, at least for those studies, long-term exposure to those notations. We decided to present participants with paper prototypes of the respective notations so we could focus on the core characteristics and not have interference with issues that were simply there because of a specific implementation. So just a short walkthrough of the study design that how we walked through with our participants. The first step to unlock participants' creativity and gather, since we were already invading their home, gather additional data on the potential for and acceptance of home automation. We let participants guide us through their homes and talk a bit about the use cases that were personally relevant to them, get them primed to really realize what kind of devices they already had in their home. They were then left with the instructions for the respective notation and the paper prototype materials for it, and we revisited them 1 week after to talk with them about the processes that they had modeled with the notations and their opinions of the notations, and a bit more in-depth information on what they felt home automation was doing to their lives. Additionally, we devised recognition tasks to see how participants would respond to the respective other notation. But we found that both notations were comparably recognizable, and this didn't yield any interesting additional results, so I will leave it out in this talk. On this slide, you can see the materials that we gave participants for the paper prototypes. Both groups got a respective manual that detailed a notation that they were supposed to use, pen, several large sheets of paper, adhesive tape for paper-related emergencies. And then the rule-based group got the yellow sticky notes for devices and actions that they were supposed to put in the trigger and action columns, while the process group got the different colors, where they put devices on the green sticky notes, they would put logic operators on the pink ones, and then they could use the orange sticky notes to reference a process, again as a sub-process in a bigger one, which kind of depicted the chaining of automation sequences. Regarding the meat and bones of our study, we had 12 households with 18 participants, where the ages ranged from 21 to 67, but of course the participants were heavily skewed, as always, to the 20 and 30-somethings. Participants lived either alone, as a couple, or in shared living situations, and we would have liked to include family households, but we couldn't since none volunteered to participate in our study. Overall, participants were pre-selected from a bigger recruitment pool, so we could make sure that the groups for the two notations were balanced with regard to several characteristics. All in all, participants came up with about 249 use cases for their homes, and 129 of them they actually modeled with the paper prototypes. Kind of evenly distributed between the groups, which we are really glad. We didn't expect that. And the subsequent semi-structured interviews gave us an additional 13 hours of material to analyze. I'm going over the insights now, but since it's a Tokai paper, there's a lot more that you can find, so I'll just go over the highlights and refer you to the paper to see more of that. What you can see here is examples of the use cases that our participants modeled. On the left side, 2 examples from the rules group, and on the right side, 2 examples from the process group. Regarding notations, we found that participants from the process group used on average more devices per use case, which can be kind of seen as a complexity measure. And they also modeled less behaviors that we refer to as simple behaviors, where only one triggering event leads to one resulting action. So the process group used less of those than the rule participants. Most process participants found their notations suitable for simple and complex use cases, while only about half of the rule participants felt the same for their notation. Rules were, however, more pronouncedly described as simple and straightforward, but both groups found their notation to be efficient. Process users overall found their notation to be intuitive, while some rule users valued the structured approach of their notation. In both groups, about half of the participants thought they could model all imaginable use cases that they might ever come up with their notation, but two rule users stated that this would not be an easy undertaking, that would require some bending of the notation as they understood it. With regard to criticism, rules were thought to be restrictive, inflexible, and not suited for complex use cases, while processes were deemed confusing, difficult to handle, and have the added difficulty of the unfamiliar logic operators. To sum up participants' feelings about the notations, we can say that rules are good for simple tasks, but processes just lend themselves better to complex use cases. There is no clear winner. Both notations have issues that developers need to address. And interestingly, participants tended to fuse the two notations without being primed for it, without knowing that there was another notation in the study. And they even were somewhat aware of the fact that they were adding functionality that wasn't part of the notation as they were presented with it. This leads us to believe that home automation interfaces might fare best with mixed approaches, and potentially in a way that users can decide to switch paradigms while modeling their use cases. So they can say, okay, I'm having a very simple use case, I'm going to use the rule tools, or I'm having a very complex use case, this could be more difficult, I'll use the process tools instead. With regard to the home automation and potential and acceptance, participants voiced general concerns over feasibility, cost, reliability, and especially security of home automation. And they also voiced a strong need for transparency. So why is the home doing something at any given point in time? And they strongly demanded the right for veto options to override all automation. With the use cases that our participants presented us with, they made very abundantly clear that the single user paradigm, which is still often used in home automation solutions, is simply not representative of the real world user requirements. Be it a guest, a new family member, roommates moving in or out, it simply didn't jibe with the way they were leading their lives. Overall, with 96 of the 249 mentions, participants showed very large interest in automating chores or comfort functions, like automating kitchen equipment, bathroom or cleaning equipment. And they showed comparatively little interest in automating entertainment and access control, which is strongly at odds with the home automation technology that the industry has focused on so far. So that's an interesting finding. And to just give you an idea of the proportions, about 70% of the modeled use cases fell into this home comfort control, automating chores kind of category. The follow-up is energy saving at a measly 7%, and only in third place there is security with about 6%. The reason for this is, or was given by our participants, that they wouldn't trust security functions, and in a matter of speaking, if they had to control it anyway, they might just do it in the first place. But while we think that our participants pointed us in some very interesting directions for home automation interface research, we are aware of the limitations of our study. As I said before, we could not include family households, and all our participants were German, which might also lead a bit to their insights on security. And we do think that doing the study again, or a similar study with people from different cultural backgrounds, this might not essentially lead to different, but at least to additional results. Furthermore, since we specifically wanted to target the average end user, and not, as in the previous talk, the do-it-yourselfers or the early adopters, our participants only had a very limited exposure to and a very limited understanding of what it meant to live with home automation. So this was actually done in the pre-Alexa area, just to give you an idea that they hadn't been exposed to home automation much. In addition to that, of course, it's a paper prototype research, so this can only be a start for the interface research in this area. That brings us to the ever-present question of what is next. And as a next step, we recommend that researchers combine pen and paper input on one side to retain the creativeness of participants and to get them to adopt the notations and really make them their own. with functional home automation technology, just to expose them to the modeling or to the consequences of their modeling. The effort of developing full-scale home automation interfaces for research can be somewhat reduced by employing mixed fidelity prototypes, where the interface has a large fidelity or high fidelity for the area that is addressing the research question, when the rest of it can be bare bones functional, just to give a complete image to participants, but reduce the effort of developing it. The hopefully soon resulting consumer products need to undergo rigorous usability testing, just to make sure that users have a very positive first experience, because this is a sensitive area that once users have been burned in this, they are not likely to come back. But instead, we really want them to commit fully to the idea of inviting home automation technologies into their houses. Thank you very much. Other questions?
Great talk.
Hi.
Jay Zhao from Delos. I think in the earlier part of your presentation, you mentioned smart home has not gone into mainstream. So in your opinion, what is the mainstream? Do you think mainstream is people using the interface like FTTT, doing customization, even DIY as the first presenter, or you think the mainstream is on the other spectrum, which is you buy something, install on the wall, everything works?
I tend to go with a mix of those two approaches, because I think that people will probably not accept the completely black box approach. They want to have control, and they want to have at least limited insight into how the home works. So I think we need plug-and-play appliances or smart appliances for the home, but also a way just for users to interface with their home, just even if it's just to check what the house is doing. But at least our participants wouldn't accept a fully automated home.
Got it. Thank you.
Fabio Paterno from Sena. I had the feeling that the two notations have different goals. I mean, in the sense that the rule-based is more event-driven, so what happens if some event occurs. The other one probably is more suitable for a task-driven description, so to describe, a process. How so, I mean, is it a bit like to compare, apple and pears? I mean
that was kind of the point that we thought, okay, rule-based approaches are very kind of widespread in the market that is currently reached by the smart home things, but that it just wouldn't allow to do everything with it.
Yeah.
And that was the basic idea of coming up with something that would address more functionality. But then it was the question, is one completely better than the other? And we kind of thought probably not, but we still wanted to test it in a very one-by-one comparison. And the results lead to, okay, both have their respective area of application.
Yeah, so it would be interesting to understand when it's better to use one and when it's better to use the other one. I mean, so to have kind of guidelines in this direction. Yeah.
So the rule-based approaches can be used for basically extending the remote control paradigm, when you not just want to turn something on the minute you're thinking of it, but tie that more into context situations. And the process-based approaches are more for routines that you have reliably, that are going to reoccur, and that are that basically need more steps, more intermediate steps to address that. So we think that's probably what the two notations will address.
So I was wondering how accurate what people wrote on the slips actually was, and whether it would actually have worked if it had been programming, or whether they really did not understand.
Oh, there was a huge variety. Some people were very abstract in what they wrote on the slips, and some people really broke that down into the actual technical steps that they imagined to happen in the background. So yes, some of the things would work, but a lot of were very abstract, just what people thought technology worked like, which wasn't as far off the mark as we'd originally thought, but was in a way the way that you could input it directly into a home automation interface.
Do people understand concepts of and or and not and that kind of thing?